Imagine you were staring at a doorway. But this isn't a normal doorway.
Right.
It breaks absolutely every rule of physics you thought you knew. You look through it and you don't see the room next door. You see
another point in space entirely.
Exactly. Maybe halfway across the galaxy. Or even more mind-bending, you see another point in time.
Which is where things get really controversial.
Yeah. Welcome to a deep dive into what might be, honestly, the most paradigm-shifting paper in theoretical physics this decade. Today, we're looking at an independent 2026 paper by Rodolfo Rossetti
titled Logarithmic-Spiral Tubular Wormholes in Einstein-Cartan-Maxwell Theory.
Quite a mouthful. And our mission today is to sort of cut through some incredibly dense multi-million term symbolic math. We want to understand how this paper claims to turn speculative science fiction into formal mathematical reality.
It really is an audacious piece of work. I mean, for decades, the concept of a traversable wormhole has been mathematically fascinating, but practically impossible.
Yeah, the math always hit a wall.
Right. Most of you listening know that the equations of standard general relativity allow for Einstein-Rosen bridges. But they always come with impossible caveats. What we are analyzing today is a rigorous, formal mathematical proof that attempts to solve the biggest roadblocks to traversable topology.
The level of tensorial calculus here is just staggering.
It is, and it's aimed at fundamentally rewriting the constraints of time travel and spatial shortcuts. But, as a physicist, my default stance is always skepticism. Extraordinary claims require extraordinary mathematics.
And this paper certainly brings the math. I mean, it is packed with complex tensorial equations and symbolic expansions that push the absolute limits of computation. And we're going to navigate that together. So, okay, let's unpack this, starting with the absolute biggest roadblock that has killed every wormhole dream since the 1930s.
The exotic matter problem.
Yeah. If most of our listeners already know that standard general relativity treats spacetime as a curved manifold, what is the fundamental hurdle that stops a wormhole from just, staying open?
Well, the problem is gravity itself. In standard general relativity, the curvature of spacetime dictated by mass and energy is inherently attractive.
It holds things together.
Exactly. So if you somehow manage to punch a topological hole through spacetime to create a wormhole, the sheer gravitational force of that structure wants to crush the throat closed instantly.
It's a snapshot.
It collapses before even a photon could make it through. So to keep it open, traditional models from physicists like Kip Thorne back in the late 1980s, they required a theoretical workaround. They needed a substance that would push outward instead of pulling inward.
Which physicists termed exotic matter.
That is the core of it, yeah. Mathematically, the geometry of a standard wormhole requires a fluid or field that violates what we call the Null Energy Condition, or the NEC.
Okay, the NEC.
Right. In plain terms, it requires an energy density that is effectively negative. The problem is, bulk exotic matter with negative energy density doesn't actually exist in any meaningful macroscopic way in our universe.
So it's a cheat code.
Basically. It has always been a highly improbable, somewhat magical mathematical cheat code inserted into the equations just to force the wormhole throat to stay open.
It's like trying to build a skyscraper, but the blueprints require a type of steel that anti-gravitates.
That's a great way to put it.
It works on paper if you allow for the impossible material, but you can never actually build it.
Exactly.
But Rossetti's paper completely shatters this paradigm. He entirely eliminates the need for exotic matter by changing the fundamental framework of the physics. He doesn't just use standard general relativity.
Right. He embeds a specific three-dimensional logarithmic spiral geometry into the Einstein-Cartan-Maxwell framework.
Yes.
Now, most of you listening are comfortable with standard general relativity, the idea that gravity is the bending and stretching of the space-time fabric. But Einstein-Cartan adds a completely different property. It introduces, and let me get this right, non-Riemannian spin-torsion coupling.
You nailed it.
How does that shift the playing field?
Well, standard general relativity only allows space-time to curve. The Einstein-Cartan theory adds a new geometric degree of freedom. It allows the fabric of space-time itself to twist on a microscopic scale.
The twist, not just bend.
Right. This twisting is called geometric torsion. In standard physics, we largely ignore torsion because its effects are negligible outside of incredibly dense environments.
Like neutron stars.
Exactly, like neutron stars. But Rossetti scales this up. He uses a logarithmic-spiral tubular geometry because the mathematical shape of the spiral inherently possesses this extreme twisting characteristic.
So we aren't just bending the manifold, we are physically wringing it out, like a wet towel.
A very heavy mathematical towel, yes.
But how does that replace the need for negative energy? The paper talks about something called crystal-torsion interactions acting as a geometric engine.
The math here is genuinely beautiful. In standard relativity, the curvature of spacetime is described by mathematical objects called crystal symbols. They tell matter how to move. When you introduce the Einstein-Cartan framework, you add a pure torsion tensor into the mix. Rossetti breaks down the equations governing the wormhole's throat and shows that when the standard curvature interacts with this intense spiral-induced torsion, it generates an entirely new mathematical term.
So they interact and create something new.
Right. The pure torsion sector and these crystal-torsion interactions create their own effective outward pressure.
It pushes outward completely organically.
Yes. Instead of needing a magical exotic fluid to prop the throat open, the intrinsic twist of space-time itself provides the repulsive force. The Null Energy Condition isn't just violated by a foreign substance, it is completely transmuted by this torsional pressure.
That's incredible.
The paper mathematically proves this by balancing the pure curvature sector against the quadratic torsion sector. The explicit presence of these terms proves that space-time's own geometry can do the heavy lifting.
So why should you, the listener, care about this specific detail? Because eliminating the need for exotic matter moves wormholes from an impossible fantasy reliant on made-up materials to a cohesive, self-sustaining electrogravitational object.
It's a huge step.
It means the building blocks to keep a wormhole open already exist in the geometry of the universe. We just needed to apply the right mathematical twist, literally.
And that is a monumental shift in theoretical physics. But, as any skeptical physicist will tell you, keeping the throat open in a perfectly static mathematical vacuum is only half the battle.
Here's where it gets really interesting. Because an open door isn't useful if it slams shut the second you try to walk through it. We have to talk about dynamic stability.
The classic collapse problem. Let's say you have a wormhole propped open by this torsional pressure. The universe is incredibly messy. What happens if a single stray photon flies into the throat?
It ruins everything.
In almost all traditional mathematical models, yes. That tiny bit of added energy acts as a radial perturbation. It disrupts the delicate gravitational balance, causing a catastrophic chain reaction. The wormhole pinches off and collapses at the speed of light.
Which brings us to a massive section of Rossetti's paper, the Radial Master Equation. He essentially runs a brutal mathematical stress test on this logarithmic-spiral wormhole to see what happens when the throat is disturbed.
He formulates a Schrödinger-like equation to test for stability. In this kind of differential equation, you focus heavily on what's called the effective potential.
Let's break that down.
You can think of the effective potential as the mathematical landscape that any incoming energy, like our stray photon, has to navigate. This landscape is composed of a geometric curvature part and a torsional part. Analyzing this potential leads to what Rossetti formally names the torsional shield theorem.
Wait, a mathematical infinite repulsive shield sounds a bit too convenient. How does the paper justify an infinite value without breaking physics?
It justifies it purely through the geometry of the spiral. The effective potential is directly tied to the spiral's intrinsic curvature, which the paper denotes as kappa, and its torsion denoted as tau sub c.
Okay, kappa and tau sub c.
Right. The math shows that as you get closer and closer to the actual narrowest point of the wormhole, the throat, where the radial coordinate approaches 0, the mathematical value for this torsional barrier doesn't just get larger.
What does it do?
It diverges to positive infinity.
Meaning the landscape spikes into an unclimbable wall. But how does an infinite potential stop the wormhole from collapsing?
It comes down to analyzing the frequencies of the perturbations. In stability equations, the frequency of an incoming wave is represented by omega. For a wormhole to experience an unstable collapsing mode, the square of that frequency, omega squared, would have to be a negative number.
Negative omega squared is a killer.
Exactly. That is what causes the mathematical wave to grow exponentially and crush the throat. But because the effective potential at the throat diverges to positive infinity, it acts as a rigid boundary condition. The math rigorously proves there are absolutely no admissible solutions where omega squared is negative.
So because the potential is infinitely positive at the throat, the math literally forbids the existence of a negative omega squared.
It simply cannot exist.
No radial fluctuation, no stray photon, no spaceship, absolutely nothing can trigger a collapse. The throat perfectly insulates itself against its own destruction.
What's fascinating here is how purely intrinsic this protection is. It isn't a force field being projected by a machine. It is a topological necessity of the spiral geometry. This brings us to another major mathematical proof in the paper, the Rossetti-Geometric Autonomy Theorem.
I was going to bring this up because usually when theoretical physicists try to make a wormhole stable, they have to inject massive artificial external magnetic fields into their equations to prop it up from the outside.
They do, and it always feels a bit like mathematical duct tape.
Right.
But Rossetti proves that the fundamental existence condition of this spiral wormhole is entirely decoupled from the axial magnetic potential. When you run the equations, the external magnetic fields just drop out entirely.
They just vanish from the requirement.
Yep. The wormhole is not a fragile artifact that requires an external life support system. As long as the spiral geometry has non-vanishing torsion, that infinite shield is there. It is structurally self-sustaining.
It's like discovering that a bridge isn't held up by the cables you attach to it, but by the fundamental laws of gravity itself. It literally cannot fall down. Okay, so we have a wormhole that doesn't need impossible exotic matter, and we have a wormhole that is mathematically shielded from collapsing when perturbed.
Yes.
But what can you actually do with it? That brings us to chronodynamics.
Chronodynamics, the formal mathematical rules of time travel. Now, in physics, we don't usually talk about time machines in the sci-fi sense. We talk about closed time-like curves. And Rossetti's paper establishes the exact condition for this, utilizing the Maxwell part of the Einstein-Cartan-Maxwell framework.
Let's explore that Maxwell component because that handles electromagnetism. How does electromagnetism lead to time travel?
The paper introduces what is known as the frame-dragging condition. The equations show that an intense rotation of the electromagnetic gauge field induces a massive shift in the stress energy tensor. This effectively tilts the local light cones.
To put that in perspective for our listeners, a light cone is a way of mapping out all the possible futures and pasts for a single point in spacetime. It dictates causality, cause, and effect.
And causality is strictly enforced by the speed of light. But if you have this extreme electromagnetic rotation dragging the very fabric of spacetime along with it, you can tilt that light cone so far on its side that the future direction points back into the past direction of the surrounding flat spacetime.
It loops back.
Exactly. If you traverse the wormhole under these conditions, the math formally allows you to loop back into your own past, bidirectional time travel.
But the moment you say time travel, you run into the biggest boss battle in theoretical physics, Stephen Hawking. Specifically, his chronology protection conjecture.
It is the ultimate skeptical counter-argument, and arguably one of Hawking's most famous contributions to semi-classical gravity. Hawking firmly believed that the universe abhorred a time paradox. He proposed that the laws of physics essentially conspire to prevent time travel from ever happening.
Hawking's idea is basically the universe's way of preventing you from going back in time to stop yourself from ordering that terrible takeout last night.
Pretty much.
The universe hates paradoxes. But what was his actual physical mechanism for stopping it?
His argument focused on quantum vacuum fluctuations. Empty space isn't empty, it is boiling with virtual particles popping in and out of existence. Hawking proposed that if you created a closed time-like curve, a time loop, these quantum vacuum fluctuations would circulate through the wormhole.
Like an echo.
Right. Every time the energy looped back on itself at what we call the Cauchy horizon, it would compound.
Let's clarify the Cauchy horizon. That's the boundary inside the wormhole where standard causal prediction breaks down, right?
Yeah.
The point of no return for time travel.
Exactly. It's the threshold where the time loop begins. Hawking's math showed that quantum vacuum energy would cross this horizon, loop back in time, cross it again, and pile up on top of itself infinitely. In a fraction of a second, this energy would build to an infinite divergence and violently vaporize the wormhole before anyone or anything could ever use it to travel back in time.
It's like putting a microphone too close to a speaker. You get that infinite feedback loop of screeching sound until the speaker physically blows out.
That is the perfect analogy.
Hawking said quantum energy would do that to the wormhole. But Rossetti delivers an incredible mathematical counterpunch, the torsional discharge limit.
This is where the sheer computational flex of Rossetti's paper is on full display. He analyzes the exact quantum vacuum energy divergence that Hawking predicted. But instead of looking at it in standard general relativity, he uses a massive 16-term symbolic expansion of the Einstein-Cartan framework to see how this infinite quantum energy interacts with the heavily twisted spacetime of the logarithmic spiral.
A 16-term symbolic expansion. Just the algebra on that would take pages and pages of pure tensor contraction. What does he find when he runs that expansion?
He finds that the expansion perfectly contracts into a finite bilinear invariant.
Hold on. Finite bilinear invariant sounds like a math spell. Are we basically saying that instead of the energy math spiraling to infinity and breaking the universe, the equation neatly balances out to a safe, measurable number?
That is precisely what it means. And the physical mechanism for this mathematical cancellation is what the paper calls the geometric capacitor.
Okay, a capacitor in standard electronics stores and absorbs electrical energy to prevent surges. How does spacetime act as a capacitor?
It comes back to the non-Riemannian spin-torsion coupling, that intense intrinsic twist of spacetime we talked about earlier. When Hawking's infinite loop of quantum vacuum energy hits the Cauchy horizon, it tries to build up endlessly. But the intense geometric torsion of the spiral physically absorbs the stress of that infinite divergence.
It absorbs it.
Yes. The twist of spacetime acts as a dampener. It perfectly stores and grounds the quantum feedback.
It's a universal surge protector. The intrinsic twist of spacetime safely grounds the infinite surge of energy that Hawking said would destroy the passage.
If we connect this to the bigger picture, the mathematical implications are staggering. By proving that the non-Riemannian spin-torsion coupling acts as a perfect geometric capacitor, Rossetti demonstrates an exact mathematical cancellation of that infinite energy.
It totally negates the breakdown.
Right. The math formally eliminates the radial collapse predicted by semi-classical gravity. It is a direct, rigorous mathematical defeat of Hawking's chronology protection conjecture.
So what does this all mean? Let's take a step back and look at the journey we've just been on. We started with a sci-fi dream, a doorway through space and time. But through Rodolfo Rossetti's 2026 paper, we've watched that dream transition into a rigorous formal proof. He calls this new framework torsiodynamics.
It is a fitting name for a new frontier. We have moved past the era where general relativity required us to invent impossible exotic matter just to make the equations work.
The cheat codes are gone.
That paradigm is obsolete. The intrinsic twist, the torsion of the logarithmic-spiral spacetime manifold, provides all the necessary positive pressure to keep the throat open.
And we don't have to worry about the passage collapsing when a single photon enters it, because the torsional shield theorem guarantees an infinite repulsive barrier at the throat. It is dynamically invulnerable.
Furthermore, it isn't reliant on fragile external magnetic fields, thanks to the geometric autonomy theorem. And, perhaps most astonishingly, it turns the twisted fabric of spacetime into a geometric capacitor,
Safely absorbing the quantum feedback loops that have mathematically forbidden time travel for over 30 years.
It is the formal proof of a topologically eternal passage.
You, listening right now, are sitting on the absolute cutting edge of theoretical physics. You're literally getting a front row seat to the mathematical boundaries of reality being rewritten. We've gone from speculative geometry to a framework where the universe's own twists and turns hold the keys to the cosmos.
The level of symbolic computation required to isolate these structural blocks, the pure curvature sector, the dynamic torsion sector, the Maxwell gauge sector, is immense. But it all points to a universe far more flexible and far more deeply connected than standard gravity ever allowed us to believe.
Which leaves us with one final, deeply provocative thought to mull over. A question that the paper points toward, but leaves lingering in the air. If the intrinsic twist of space-time can act as a geometric capacitor, if it can perfectly absorb infinite quantum energy to stabilize a macroscopic wormhole, could this same torsional twist be the missing key we've been looking for all along? Could the microscopic twisting of space-time be the ultimate bridge that finally unifies the macroscopic world of gravity and the microscopic chaos of quantum mechanics across the entire universe? It's a question that changes how you look at the stars. Until next time, keep diving deep.